displacement time graph first, and then later we'll talk about velocity time graphs. Okay. So let's say we have two cars. Okay, like this, A and B, car A and then car B. Now, car A is going at this shown in this gradient right here, and then car B is shown in this gradient right here. Now, just like uh, in the previous topic, okay, the gradient of a displacement time graph is the velocity of the particle or the object moving. Okay, so if you want to find out how fast and where is it going, you should just find for the gradient of this certain lines. For example, uh, car A here, uh, after 3 seconds, it's 4 meters away from the origin. And what's the speed or the velocity of this car? So you just need to basically compute for the gradient of this line right here. And I think everyone knows how to compute for the gradient, right? So if the gradient is up, the velocity is higher, okay? Then for car B, if the gradient is lower, the velocity is also lower. Okay, so we can say that the steeper the gradient is, okay, the faster the velocity. Okay, okay, and then again, class, if you can see, y is your displacement, and then x is your time. Okay, so let's have some questions. Whenever you see a straight line like this with the displacement time graph, that means that the gradient is equal to 0. So therefore, there's no velocity at all. Okay, because it didn't go up, it didn't go down. So there's no velocity going fast, or yeah. Okay, so it's just flat like that. And then what if it's like this, just like in the previous examples? Okay, so here your gradient is positive and constant, and then your velocity is also positive and constant. Okay, what do we mean by positive? Of course, it's here. Everything here is positive, right? And constant means it keeps on, okay, increasing. Okay, so in this case, you can call this a uniform velocity motion. Okay, so and then let's go with this. Okay, so whenever you see a graph like this, okay, so the gradient here is um, the gradient here is down, and then so the velocity is also down or less. Okay, and then the opposite is this one. Okay, if the gradient is up here, the velocity is also up here. So let's summarize this one. So in a displacement time graph, the velocity of the object is equal to the gradient of the graph. Okay, because class, if you're given a displacement graph, okay, usually the question here is about the velocity. Okay, so that's the displacement time graph. Now let's go with a velocity time graph. Now class, it's the same with the displacement graph. It's just that I drew this in a different way because uh, they might look like this on some questions. Okay, so anyway, this is now is a velocity time graph. From here, this is velocity, and then this is again time. Okay, so when your graph looks like this is a positive gradient, and then this one is a negative gradient. Okay, so in a velocity time graph, so the graph here means acceleration. Okay, so they're portraying or they're showing the acceleration of a particle or an object. Unlike the displacement graph, it's showing the velocity or speed of an object or particle. In this case, this is all about acceleration. Okay, so again, this is constant positive gradient. So this is acceleration, and then this one is deceleration. Okay, and then of course, if you see this flat lines here, this means velocity is constant, so there's no acceleration here. A is equal to 0 on this flat lines. Okay. All right, now class, you might encounter some questions like this. Okay, if it's asking for the distance traveled, so you just basically find the area under the line or a curve. Okay, so for example, let's say from origin to point A, what is the distance from point O to point A? So to compute that, just find for the area of this triangle right here. So we can say that the distance is by just computing the area of the triangle, which is, let's say, 2 times 3 divided by 2, right? So we can say that the distance of O to A is 3 meters. Okay, yeah, that's 3 meters. So that's one phrase that you might see commonly in this type of questions. Okay, so that's the velocity time graph. So to summarize that, in a velocity time graph, the gradient is equal to the acceleration. Okay, this is acceleration. Okay, and this is has no acceleration. It's a flat line. Okay, now let's have some questions. This questions came from the book. Okay, so you can turn to the next page. And let's have question number 7. So this diagram shows a velocity time graph of a particle P moving a straight line. So this is the particle. Okay, this one. Now, first, you describe very briefly the motion of the particle. So just look for the keywords. So P moves with a constant velocity. This is your constant velocity from the notes that I showed you a while ago. Okay, because it's a flat line, that means it's constant. It never changes. Okay, so it started with a velocity of 20 meter per second. This one. This is your velocity. Every number here is the velocity. Okay, so 20 meter per second for 10 seconds. Okay, this is time, so that's 10 seconds. And then after 10 seconds, it decelerates. Okay, decelerates for the next 15 seconds to a velocity of negative 10 meter per second squared. Okay, how did I get negative 10 meter second squared? Okay, from here. Okay, so it's a negative. Okay, right. It's not squared. It's supposed to be just so. Okay, sorry. So this is just one. Okay, just meter a second. Okay. So that's it. That's the simplest description for question number 7, letter A. Okay, then let's go to letter B. Okay, letter B, we need to find the deceleration of P for the interval t 10 seconds to 25 seconds. So you can see, class, it's over here. This is 10, and then this is 25 seconds, right? So if we need to find the deceleration of this particle, again, class, we just need to compute for the gradient of the line. Okay? Acceleration, deceleration, velocity. Class, because look, we are given a velocity time graph. That means most of the questions here are about acceleration. Okay? So to get the deceleration of this, just compute for the gradient of, let's say, line AB. By the way, class, we just added this letters here just to indicate lines and some segments. Okay? So let's say the gradient of AB will give me the deceleration for the interval. So how do you compute for gradient again? Okay? So if I don't know if you still remember this formula, but again, the gradient is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You still remember that formula? Okay. Coordinate, coordinate geometry. Okay. Okay, so basically you need to choose 2 points, right? In this case, I chose this one, point A, and then point B. So the coordinates of point A is 10, 20. B is 25 and negative 10, right? So So let's say this is my x sub 1, y sub 1, x sub 2, y sub 2. So just replace, just put this in this formula, and then you'll get this right here. Okay. So that's why this is 20, okay, minus negative 10. This is negative 10, right? So this is y sub 2, this is y sub 1. And then, of course, it's 10 minus 25. So getting that, the deceleration is negative 2 meter per second squared. So that's the deceleration for letter B, okay, from 10 to 25 seconds. Okay, this is your answer. Now, for letter C, we need to find the time when P is instantaneously at rest. Okay, so we find, okay, so we have encountered this phrase again. So class, when something is instantaneously at rest on a given graph, that means that the time is 0. Okay, or the velocity is also equal to 0. Okay, it's over here class, indicated by this red dot over here. Okay, so that means that there's no velocity there here. Okay, because here is your velocity, these are your velocity, right? So this is 0, so therefore yeah, it's at rest. Okay, okay, so how do we do that? So we know that the gradient A, okay, how do we find the time here? Okay, we know that the gradient of this line is negative 2, right? So finding this, the gradient of AC is also negative 2. So to find for the time, or the y value of this, we just need to apply the gradient formula again. Okay, so A is equal to the gradient of AC, so it's negative 2, right? Came from here. So how do we compute for the gradient? So basically, class, it's again, A is your, this is 10, 20, but then for point C, it is now um, T, okay, Tn 0, okay, Tn 0, because T is your x-axis, right? And then 0 is your y. And then yeah, it so happen that that's your velocity as well. Okay, so to get this, so y sub 2 minus y sub 1, so 20 minus 0, and then x sub 2, or 10 minus t. That's why I got 10 minus t over there. So that's how I got this. Now, how do you solve for t? So we just cross multiply this. Therefore, your t is 20, or 20 seconds. So that this is 20 seconds. Okay, so that's your answer for letter C. Okay, it's 20 seconds, or it took a rest, or it's instantaneously at rest at 20-second mark. Okay, now let's go to letter D. So letter D, we find the total distance traveled in the 25 seconds. Okay, so again, if it's asking for the total distance, class, you just need to compute for this area. Okay, sorry, it should be bounded by the x-axis. Sorry, this one. Okay, and including this one right here. Okay, so how do you find for the area under the graphs bounded by the x-axis, or the time axis? Okay, so basically, class, you have this shape here. This is a trapezium, and this one here is a triangle. So this is a trapezium, and this is a triangle. Okay, so to get the distance, so you just find the area of the trapezium, OCAD. Okay, if you want to write D there, but you don't have to write these letters. It's optional. Okay, so find the area of this trapezium, wherein I got, what's the formula for trapezium? 1/2 A plus B times height. A and B are the top and bottom part of your trapezium. Those are the two parallel sides. This is A, this is B, and of course this is height. Okay, so this is 10. Okay, that's 10, and this is 20. Okay, from the question from letter C. So this is 10 plus 20, and then what's the height? The height is 20, and then times 1/2. Okay, and then basically, you see this small triangle here, so it's 5 times 10. So this is 5 because this is 20, so this is just 5. And then the height is 10 because this is 10. The distance is 10, and then over 2 because it's a triangle. So computing for the area or the sum of the area, the total distance after 25 seconds is 325 meters. So from here to here to here, that's 325 meters. Okay. But then for letter E, we need to find for the distance of P from its starting point after 25 seconds. Okay. Okay, now class for letter E, there's a slight difference. Okay. Since the question is about the distance of P from its starting point, okay, not the total distance traveled, okay, you should consider the displacement of the particle. As you can see, class, this triangle here is below, okay, below 0. We can say that this triangle here is negative, right? If you remember the, finding the curve or finding the area under a curve, whenever your shaded area is here, it's negative, right? Okay. Same with this. Okay. So there's a slight change in displacement. Since this part here is negative, we should subtract this from the total. Or since this is negative, it will be subtracted from the total distance. Okay. So if that's the case, so we basically again still get the area of the trapezium, this one, but then this triangle, since this is below the, let's say, the x-axis or the time axis, that becomes a negative now. Okay, so instead of adding them, we subtract them, and your answer is 275 meters. Okay, so that's your answer for number 7. Okay, maybe last example, one more example. Okay, okay, this one. Okay, now class, um, this one, it involves sketching. Okay, sketching means drawing, right? So I did this last night. All right, let me read the question first. Okay, so number 8, a car accelerates uniformly from rest. That means it starts from here. So note time is 0, velocity is 0. Take note, this is a velocity time graph again. At a rate of 1.5 meter per second squared, okay, so this is the rate of the car, okay. It accelerates at 1.5 meter per square second, okay, and to a speed of 12 meter per second, okay. So 12 meter per second is this one. Okay, class, it's up to you how long or how short you're going to tell that it's 12 meters. You can write it here and then just label that 12. It's fine. Okay, when you sketch this, don't forget to label the 12 meter per second because that's the speed, right? Speed and velocity, this one. Okay, so it stopped right here because that's your 12 meter per second mark. And then it continues moving at 12 meter per second. Okay, so it continues at this speed. Okay, continues moving at 40. Okay, so let's say this one. So it continues moving at this speed. Okay, while consuming time. Okay, 40 seconds. But later we will find out what's this or how long did it, travel at this speed, constant speed. And then after t seconds, it decelerates. Okay, for 10 seconds. So for 10 seconds, it goes slower and slower until it reaches a full stop here. Okay. Okay, so this is the travel of the car. Okay. So the blue line is the sketch of the velocity time graph there. Okay. Okay, now, how do we solve the following question? So let's have letter B. Find the time taken while accelerating. Okay, so it is accelerating here, right? So the acceleration is 1.5 meter per square second. So the question here, class, is what's the time covered? So what's this part right here? Hmm? What is this part right here? Class, you can just take the gradient of OA and then find for, rise over run, okay, or y over x. Okay, so that's what I did here. So since the acceleration is 1.5, so the gradient of OA is 1.5 equals 12, okay, then divided by t, okay. So plus this is y squared minus y1. No need to compute for that. So it's already indicated here. This is 12, and then this is t for time. This is your x sub 2 minus x sub 1 from the formula. Okay, so solving for tt is equal to 8 seconds. So you can change this or maybe label this 8 seconds. Okay, so 8 seconds because we will be using that as well later. Okay, all right, so that's letter B. So the time taken for its acceleration is 8 seconds. Okay, all right, now let's go to letter C. Now, letter C, we need to find the distance move while accelerating. Okay, so again, this is the acceleration. So how do you find the distance from here to here? Again, we're talking about distance. So finding the distance means finding the area below this triangle right here. Okay. So area under OA. By the way, class, I just labeled this A. If you don't want to label this point here, it's fine. Okay. But I'm doing this so you guys can see where's the line. So area under OA or triangle OA. Okay, so just get the area of OAB, or you can write B here as well. Okay, so that's 8 times 12 divided by 2. So 8 times 12, then divided by 2, that's the area. That's also the distance from O to point A. So after accelerating for 8 seconds and reaching 12 meter per second, okay, so the distance covered is 48 meters. So plus this is 48 meters from O to A. Okay, so and then let's have letter D. Now, letter D is the last question, class. So given that the total distance moved by the car is 852, find the value of T, this one. So you need to find for this one. Okay, so this was from the second sentence, right? The particle continues to move at 12 meter per second. That's his speed, constant speed for this amount of time. So we need to compute for that time now. Now we are given that the total distance from here to here, traveling this is 852 meters, and that also translates to the area below the this shape. Okay, so in order for us to get t, we'll just use the formula for finding the uh, the area of a trapezium because this is one trapezium here. Okay, so for letter D, so the total distance is 852. That's also the area under the graph. So area of trapezium is equal to 1 half AB times height. So this one is 852. Then what is A? A is T. This is T, right? It's T. And then what is B? B is this. Okay. We know that T here is 8 seconds, right? So this is basically 18 plus T, right? That's why I got here 18 plus T. And what's my height? My height is this, which is 12 indicated by this. Okay, so we have all that we need. So solving for T, that's 62 seconds. Okay, so this is 62 seconds. Okay, so that means that the car was traveling at 12 meter per second for 62 seconds. So it maintained its speed for 62 seconds. Okay, before decelerating here. Okay, so that's your answer for letter D. Okay, class, do you have any question for this example? Yeah. Probably one more very short example. This is example number 10. We can go to the next page. Okay, so let me read the question here. So a man P running along a straight road passes a point A at a constant speed of 6 meter per second. 12 seconds later, a second man Q running in the same direction as P passes A at a constant speed of 10 meter per second. While Q overtakes P at point B, where AB is equal to S meters and T seconds after P left A. And now draw on the same diagram the displacement time graphs for the motions of P and Q from A to B and evaluate S and T. Okay, so class, let's go with the first sentence first. So a man denoted by this line, so this is P, passes at point A. So point A is the point of origin, okay? And then his speed is 6 meter per second. So this is, yeah. So you can just randomly draw a line, okay, like this. Of course, it's going up because speed is constant, so the gradient is constant as well. Okay, and then for the second sentence, 12 seconds later, so this is zero time, this is 12 seconds, okay, because this is your time axis. So after 12 seconds, second man, so the second man is Q, okay, so just draw another line, but you should intersect this line or line P, okay, why? Because Q here will pass through or will overtake P. Okay, and then this point of intersection is your point B. Okay, this is B or B, this one. Okay, since this is the displacement. Okay, and then where AB is meters, so this one. So the distance from here is meters, and this is of course T seconds. So the question there, class, is what is the value? I mean, what is the value of S and T? So what is this? This is S and this is T. So what is the, let's say, simply class, what is the distance, okay, until they meet here, until they intersect, and then how long did it take it for them to intersect, okay? So for that, we just need to refer from the velocity of P. Let's start from here. So the velocity of P is 6 because it's also the gradient, right? So using that, okay, so let's say this is your line. So why is this S over T? Because this is S here, this S, and this is T seconds. Okay, so this is, if you remember the phrase uh, rise over run, okay, compute for this first divided by the x-axis or the horizontal line. Okay, so that's S over T is equal to 6. So this is your gradient formula. And then solving for that, S is equal to 6T. And then solving for Q or the velocity of Q, so this is the gradient of Q, is equal to 10. Okay, so how do you get this one? Okay, so what is the height? I mean, what is the this one? So this is S, right? This is S. Okay, and then how do you indicate this? So by the way, this one, this is T minus 12 because this is T, right? And then if you want this portion, this is T minus 12 because this is 12 seconds. So the remaining is T minus 12, okay, equals 10. So simplifying this, I'll express this in terms of T. So S is equal to 60 and then S is equal to 10T minus 120. So solving for T, if these two are equal, okay, so this one, okay, so T here is 30 seconds. Okay, so this is 30 seconds now. Okay, so that's 30 seconds. And then to solve for S, you just choose one. So you can choose this. So 60 So your answer is 180 meters. Okay. So